Good morning, everyone, and thank you all for coming and joining our Aquafix webinar series. My name is Deborah Lee. I'm the microbiologist with Aquafix, and I've been working for the company for about 10 years now. We're just going to jump right into our Wastewater Lagoon Sludge webinar. So as people kind of trickle in, they can just join wherever we are. So starting off today, we're going to go through what sludge is made out of. We're also going to cover how does sludge build up in the lagoon. So some issues that sludge can cause is algae and high TSS. You might also get poor nutrient removal with high sludge buildup. You would also get high BOD, effluent BOD, and also high effluent ammonia or phosphorus. And you might even get some odor issues with a lot of sludge buildup. So this is also why we developed Sludge Rx. We will go over how it is different from the more common dry bacterial packets that some of you may be familiar with. We're also going to cover some of the metagenomic and other data from our lab testing. We're going to also then cover using Sludge Rx and how to apply it. We'll go over application rates and other considerations for how and when to use Sludge Rx. And last, we will go over how OxyPaks XL can complement a Sludge Rx treatment and go over OxyPaks XL application rates. So what is sludge? Starting off, it's that brown or black stuff under the green liquid here in this container or in your lagoon. So sludge is a blend of organic and inorganic particulates that accumulate to form a soft sediment layer on the base of a water body. Within the sludge, there is a diverse community of microorganisms and macroinvertebrates. There are also often sizable amounts of decaying plant material, algae, bacteria, and in many cases animals. Sludge is a source of carbon, nitrogen, and phosphorus, along with micronutrients and vitamins that make up an internal nutrient reservoir. Sludge is a rich source of carbon, nitrogen, and phosphorus, and all the nutrients at the bottom of the pond make up that internal nutrient reservoir. The nutrients will be released into the overlying water under certain conditions. The released nutrients will then contribute to the total levels of nitrogen in the water, even without other inputs or nutrients. Some of the nutrients released from sludge include nitrogen in particulate forms, phosphate in particular forms, lots of carbon, and various amounts of metals. In addition to nutrients released from sludge, different nutrients tend to migrate in different ways and often come into the lagoon from different sources. The time nutrients can stay in a system varies greatly depending on specific lagoon conditions. Nutrients that promote the growth of algae, plants, and bacteria can lead to effluent quality issues and sludge buildup in the lagoon. One thing of note, sludge often contains high levels of organic compounds. These compounds will swell more with water, while inorganic particles, such as sand, do not absorb water. So here's an example of a dry polymer. You can consider it like your organic polysaccharides and other compounds. And once it's exposed to water, it begins to absorb all of that water and soon takes up the entire volume, but it's still mostly composed of water, not really solids. So even though you can shovel some of the sludge sometimes, say in this form, when you have it analyzed for total solids, you find that most of that volume was water. So sludge with high levels of organics can lead to a higher volume of sludge, as we see here, but it's a volume that's not very well compact and not very dense. So you can lose its structure easily or be moved around easily with underwater currents. However, sludge that has more inorganic particles can lead to more compacted sludge that does not easily resuspend into the water column. Organic compounds can be degraded by bacteria, while inorganic particles cannot be degraded and do have to be physically removed. Water is always moving around in these lagoons, even near the bottom of the sediments, and the water currents can move the sludge around too. When mixing happens in sludge, inorganic particles tend to move downwards because they are denser than the organic compounds. This leaves distinct layers with mostly organic compounds on the top of the sludge. Almost the entire sludge depth in a lagoon is anaerobic, except for that very top few centimeters. Now we will go over the process of sludge formation. Nutrients and particulates flow into the lagoon, or they're released from sludge in the pond. The nutrients promote the growth of algae, plants, and bacteria. The algae, plants, and some bacteria will eventually die, then sink to the bottom of the pond and increase that sludge layer. The increasing sludge depth then generates a larger anaerobic sludge area, still with organic compounds in it, and that promotes the release of more inorganic nutrients. And this is how this process keeps repeating. So in the sludge layers, only that very top few centimeters, this lighter brown here, is considered to be aerobic, and that's in a good case. The darker brown area underneath it is the anoxic layer. The bulk of the sediment height, this dark brown, is anaerobic. The anaerobic layer is where most of the inorganic nitrogen and phosphorus are released, and then they move upwards into the water column. This is how sludge acts as that internal nutrient reservoir for the water column and perpetuates the growth of algae and plants. So in the deeper layers, about a depth of greater than 5 centimeters from the surface, that sludge is anaerobic. Organic carbon in anaerobic sludge is slowly degraded by microbes. And the nutrient in the sludge is often not well balanced for anaerobic digestion. So there is generally always an excess of nitrogen and phosphorus compared to the amount of carbon that's being used. This leaves free nitrogen and phosphorus that migrate up through the interstitial water into the water column. So the excess nitrogen and phosphorus, generally in the form of ammonium and phosphate, they're released from that anaerobic or sometimes just anoxic sludge, and they travel upwards into the water column. Normally, the free nitrogen and phosphorus from the anaerobic layers will bind to sites on particles in the aerobic zone. However, if there are high levels of nitrogen and phosphorus being released, all the sites in the aerobic zone will become filled, and that free nitrogen and phosphorus will be released into the water column. Some metals can also be released in this manner as well. The soluble ammonium and phosphate are used by organisms in the water column, mostly algae, to grow. This may lead to a bloom of algae, sometimes bacteria if you also have high amounts of soluble organic carbon in the water. And these planktonic organisms will lead to higher effluent TSS and possibly higher effluent BOD or ammonia. After some time, the algae and bacteria will die, and their cells sink to the bottom again and contribute to this buildup of sludge and further the anoxic or anaerobic conditions, leading to release. So this cycle will continue. Some impacts from sludge accumulation include increased soluble nutrients such as nitrogen and phosphate, metals that migrate up into the water column, also increased algae. Here's some examples of Desmodesmus and Dictyosporium, oftenly found in wastewater polishing lagoons. Not only the increase of algae, but you might actually get some plant growth and also bacterial growth in the water column, and that may lead to increased effluent TSS or effluent BOD. So something to remember is some of these algae, they're photosynthetic organisms, so they can make their own fixed carbon, which will count as sometimes soluble BOD. They overproduce it and actually might start releasing some of that into the water column. Certain algae, I don't really have a picture of it here, can also be very difficult to manage because Dictyosporium, which I know, has a slime layer that's very thick and distinct, and it's not really possible to get many chemicals into it. In most wastewater lagoons, the presence of sunlight and nitrogen and phosphorus will promote the growth of algae. So in water, again, with high soluble organic compounds in this situation, you will promote the growth of free bacteria. So there are some difficulties in controlling sludge buildup. Dredging is the most commonly applied method for sludge reduction. However, it can be difficult to find a place to relocate that dredged sludge to. Sometimes dredging is expensive, also due to metal concentrations or other contaminants that would count it as a hazardous waste. Dredging may also cause a temporary increase in suspended nutrients and can also release malodors, such as sulfates or sulfides. Dredging may also lead to the release of toxic material from the sediments into the water column. Some examples include arsenic. When arsenic is buried in the sediments, it is not bioavailable. When the sediments containing arsenic are disturbed, it can enter the water column and act as a toxin. Sulfate or sulfur in anaerobic sediments is converted to sulfide, H2S gas, that can be released into the water column, and this will decrease your overall dissolved oxygen content and can also lead to the release of bad odors. Sulfide in sludge or the water column will scavenge oxygen and decrease your overall DO and can make a low DO situation even worse. Dredging may take out the lagoon sludge aerobic layer of sediments, and that might expose more of these anaerobic sediment layers. This may cause low DO, poor BOD removal, and bad odors in the lagoon. And it is necessary and beneficial to dredge a lagoon that is filling in with inorganic sediments. However, just remember that in the short term, it can release to anaerobic nutrients, possibly toxins, and probably lower your DO. However, sometimes it's the only thing you can do to really recover your lagoon volume capacity. In these situations, most of these conditions, such as your inorganic nutrient release, and bad odors, is generally caused by low DO from disturbing that sediment layer. And if you add OxyPaks XL or potassium permanganate to lagoons, particularly lagoons that have black water, it will help you sort of recover that oxygen capacity. For lagoons with sulfide odors or anaerobic odors that have brown water and low incoming sulfates, it's recommended that you meter in OxyFresh liquid to increase your lagoon dissolved oxygen levels. Sludge Rx will reduce the need for dredging by reducing sludge volume and limiting the potential for nutrient release from the sediments. Dredging may still be necessary, but will need to be done less frequently. Aquafix has been studying biological methods for sludge reduction since 2012, and this led to the development of MD pellets and then later Sludge Rx. So Sludge Rx is a tablet technology. Unlike other bacterial amendments, Sludge Rx represents targeted sludge reduction. The dense tablets will sink into the sludge and deliver bacteria and biostimulants directly to where they are needed. This allows the operator to focus the treatment on areas of greatest sludge accumulation. With the tablet delivered directly into the sludge, all of the ingredients remain in the area of treatment, making it the most efficient possible sludge reduction approach. This allows application to happen as infrequently as once per month. So Sludge Rx can be applied in all weather conditions, and the tablets can be broadcasted evenly over the surface of the target area, either by hand or with a mechanical spreader. Sludge Rx contains a synergistic blend of bacterial cultures and biostimulants, and that combination helps to dramatically reduce the sludge and nutrients in wastewater lagoons. So the dose rate for Sludge Rx is 30 to 60 pounds per acre once per month. It's better to apply the tablets evenly over the surface of the targeted area. I've done it by hand. It just might take you a while. Some people use mechanical spreaders of various types. It's okay to concentrate more in a larger area, especially with a higher depth of sludge. Though I don't recommend sitting there with a bucket and just dumping it straight in. The application for Sludge Rx can happen as infrequently as once per month. So we developed Sludge Rx based off of our successful MD pellets that were also used for sludge reduction. The Sludge Rx tablets, they have a different shape and consistency compared to the MD pellets, and this aids in spreading and sinking. We have performed lab studies to determine sediment reduction using Sludge Rx, and we are working on understanding the bacterial mechanisms in biological sludge reduction. We are also examining whether nutrient reduction is a consistent side effect of bacterial sediment reduction. So these are 15-gallon standard fish tanks that we used for our lab testing. The tanks were cleaned, and then we added a layer of wash sand, then clay, and then pond sludge that had been frozen and thawed. 2 of these side pumps were set on a timer to be on for 15 minutes, and they were added to a controller to alternate their on times every 10 seconds. These pumps ran once every 6 hours just to give a general mild bottom lateral movement over the sludge. The aerator at the back was only turned on at night when photosynthetic organisms consume oxygen. The tank sides were covered with foil to prevent external light, just to keep things consistent among the tanks. Light was provided directly from the top using a standard fluorescent aquarium light bulb on a light-dark cycle of 12 hours on, 12 hours off. A grid of 3-inch squares was constructed over the top of the tanks. Every square was measured for soft sediment depth weekly, and water quality was also measured weekly. We took water from about an inch or 2 off the top of the sediments. So we observed sediment reduction in our lab tanks using Sludge Rx. The control tanks did not have as great a sediment reduction. The trend lines in the Sludge Rx tank, this dark blue one, showed a faster sediment reduction than the control tanks, the light blue one. The percent of total sediment reduction by the end of the test was, for Sludge Rx, about 11% decrease from that initial week at 0. The control actually increased compared to week 0 by about 4%. If we take it from the control's highest sludge depth at week 1 and compared it to the end, we did see a decrease of about 5%. So we also examined the sediments in those tanks for the bacteria and archaea composition and distribution between the initial muck, the control tank, and the tanks treated with Sludge Rx. We saw there were significant differences between the control tank and Sludge Rx tank for 2 bacterial genera. The control tank had 11.2 times more acidiothiobacillus than the Sludge Rx tank, and also had 1.6 times more Aphanizomenon flossaceae than the Sludge Rx tank. Now, Aphanizomenon is a cyanobacterium. This indicates, based on what we were seeing in these distributions, that the control tank had more anaerobic hydrolysis of organic carbon, while Sludge Rx tanks had more microbes that were associated with a lower total organic carbon. So we think the control tank was probably still in the anaerobic hydrolysis phase, while Sludge Rx tank had already progressed on to that, perhaps to full methanogenesis. So if we see here, the tanks treated with Sludge Rx, they were dosed every month for 3 months with 12.5 pounds per acre. The tanks treated with Sludge Rx had a lower total volatile solids than the other tanks and the initial. Also a lower total nitrogen and a lower total phosphorus in their sediments. For the most part, the control tanks were about the same or slightly lower for nutrients than that initial starting sludge. This is our latest research and results from the lab tanks, where we did the same setup again, compared Sludge Rx tanks to control tanks, and also treated a small pond that was the source of the sludge used in the tanks. So this pond is very, very small. It's 0.015 acres by about 4 feet deep, and it had an average sludge depth of about 20 centimeters. We took about 7 points within the pond. The pond was also treated with 12.5 pounds per acre of Sludge Rx once a month for 3 months during our summer. So summer of last year, there was only a slight reduction of sludge depth in our tanks, about 7% reduction in the Sludge Rx tanks, and the reduction was slightly faster in the tanks treated with Sludge Rx compared to the control tanks. The control tanks had about a 3% sludge increase in this test. So just a note, the tank water in these tests were replenished weekly with water from the pond that the sludge was from. And the pond had a continuous algal bloom during this entire time. and that may have contributed to both a lower total sludge reduction in the Sludge Rx tanks and also an increase in sludge in the control tanks. In the pond, the source, treated with Sludge Rx, there was more dramatic sludge reduction than in the tanks. There was a 30% reduction in sludge in the pond over the course of this season, so 12 weeks. So the total phosphorus in the tanks mostly depended on what the levels in the pond water were. The pond water total phosphorus mostly decreased during the test and then increased around week 9 and then climbed back up to their starting levels. This may have been dependent on rain events as well at the time. The orthophosphate in the tank water, it did decrease throughout the test, and the pond water orthophosphate was more erratic, but generally decreasing during the test as well. Something that was interesting when we looked at all our data was we saw that the pond water orthophosphate levels was inversely correlated with the pond water DO levels. So the DO was measured at about 1 foot off the top of the sludge in the pond, and the DO may have been dependent on pond water temperature at the time. Also, this pond was not aerated at all. It just sat there. With deeper levels of soft sludge in the lagoon, this release of orthophosphate and maybe even ammonia will be more apparent with even a slightly lower DO in the water. So on the graph, a water DO of about 2.3 milligrams per liter is right where the tipping point is for that release of orthophosphate. At least that's what it seemed to be for us. When our DO fell below that, our phosphates started skyrocketing. So Sludge Rx, total volatile solids, was lower than the initial, and then the control in the end of the tanks. The lagoon or pond, total volatile solids increased over the course of our testing, and that may have been also due to just that continuous algal bloom that was present the entire summer. The tank total nitrogen was lower than with Sludge Rx than in the control tanks, and also lower than the starting muck in the lagoon. In that situation, since it was a residential pond, a lot of nutrients may have also been running in from nitrogen and phosphorus in the fertilizers because they did have a very nice green pond and a lot of very nice bushes and stuff around it. So here's an example of Sludge Rx used in the field. A winery wastewater customer had a 0.1 acre pond used as an aeration basin to decrease soluble carbon BOD. They added 2 pounds of Sludge Rx into this 0.1 acre pond, and that comes out to about 20 pounds of Sludge Rx per acre. They did this treatment for only 2 months. And after 2 months of treatment, the operator said they decreased the number of aeration units in the pond, and they also noticed a decrease in odors and lower water turbidity. So OxyPaks XL is a granular oxygen source that is used in wastewater lagoons and also decorative ponds to accelerate the digestion of sludge and muck and also to prevent odors. OxyPaks XL is an oxygen booster and it releases oxygen into the sludge and muck for 30 to 45 minutes after application. This will often cause undesirable muck to rise to the surface where it is easily consumed by Sludge Rx. Sludge Rx and OxyPaks XL are also a good combination for wastewater operators with lagoons. The lagoons tend to build up with dead organics in their sludge. This causes the lagoon to lose effective volume and can release soluble nutrients such as nitrogen and phosphorus into the water column. This will lead to higher effluent values. Soluble nitrogen and phosphorus released from sludge can also promote algal blooms that can increase effluent TSS levels. The use of both of these products helps break up and digest organic matter so the water is clean again. The dose we recommend for OxyPaks is 100 pounds per acre for very aggressive sludge reduction. Thank you. So the question we have here is, can adding more than the needed amount help with the sludge reduction? And yes, it can. However, that comes down to a matter of cost efficiency, where you can go over our recommended doses, but it might get very expensive. Another question is, are these products used in anaerobic lagoons also? We generally see very good results in aerated lagoons. However, we have used these products in a few anaerobic lagoons and did see some sludge reduction. Okay, another question we have is nitrogen seen as PNBOD? Sometimes. I'm not sure the NBOD is really considered for something like ammonia, which I believe is inhibited in a lot of those BOD tests just because of nitrification. Not sure if it's a common measurement there. I would look more at total nitrogen levels. Okay, so is there a way to differentiate the BOD released from sludge from the incoming BOD? Um, Possibly. So you might have your influent BOD numbers in the liquid, and you might be able to take a sludge sample and approximate the BOD in that, or take water off of maybe a foot above the surface of your sediment layer and see what that BOD comes out to and compare the two. And it might be higher or lower depending on where you took your influent or incoming BOD levels from. Generally, water 1 foot above the sediment layer is usually 1 or 2 feet above that sediment top layer is what we want to look at when we do water quality analysis, especially in these situations. So the top water of your pond is probably going to be always very low in nutrients, just because there's a lot of organisms using up a lot of those nutrients, and unless you have a huge amount of incoming nutrients, most of that nutrients in the water column is going to eventually come up from the bottom in the sediment layers. Another question we have is, can you use a product in conjunction or with ferric chloride for phosphorus? I'm not entirely certain about that, since ferric chloride's generally used on your effluent or to polish your effluent from the clarifier. I have heard reports of using a lanthanum product for it. I'm not too certain if that's a way you want to go. It is pretty expensive. But generally, those two should be able to be used together. You'll just possibly have excess ferric or lanthanum in your effluent. A question here is, a lake with sludge created by algae, can we apply this product? I would say that is definitely what this application was for. So algae that have died and fallen to the bottom and created a sludge layer, that's going to be very high in all nutrients, so carbon, nitrogen, and phosphorus. And we do know that with repeated use over the seasons of Sludge Rx on the bottom of a pond that has a lot of algae on it or lake, um, you do eventually see less algae blooms or less intense algae blooms, and it could just be because of that reduction of the sludge layer. All right, we have another question here. In a 5-pond system, which pond should you attack sludge? If you use in the first pond or 2, will that reduce sludge in the next 3 ponds? That might really depend on the situation you're dealing with. The closest thing I remember treating was a golf course that had a situation where there were 3 ponds in series, one into the other. And yes, when we saw the sludge build up in pond 2 and treated that one, we saw less sludge in pond 3 and also um, less algae blooms, which is mostly what they were concerned about. So it could be done. I would really recommend in a situation with different ponds flowing one into the other that you really find out where the sludge is accumulating and then just target it in those areas rather than treating, say, the entire volume of the pond. Okay, well, if there are no more questions, then I would like to thank you all for coming and attending this webinar today. So thank you, everyone. Have a good day.